Hi and welcome to this C# tutorial video. In this video, we'll be looking at the different data types and some of the ins and outs with these data types. So let's go ahead and let's just create a new project again here. And we're going to be creating once again just a C# console app. And we're just going to name this one variables. We're just going to click on next here, and we're just going to create a .NET 6 console app. All right, so we can go ahead and actually just erase all of this here. So what we're going to be looking at in this video, like I said, is going to be the data types. So we're going to be going over how to initialize a variable, and then some of the different variable types and what we can do with those variables in C#. So compared to PowerShell and Python, where we could just initialize a variable and put anything that's in there, C# is not very much the same. We are going to have to actually initialize our variables with a type and then assign those variables values specific to that type. We cannot mix and match them without doing some conversions, which I will also be showing in this video. So the first type, as we've probably know by now using PowerShell and Python, is going to be the integer. So to create a integer variable, we are going to actually go ahead and type in int, so just int all in lowercase. And then we're going to give our variable a name here. So we're just going to call it my integer. And we're going to set that equal to, let's say, 2 for now. So as you can see here, I named my variable starting with a lowercase, and then the second word I started with an uppercase. So that is actually a naming convention in C#. You're going to want to use, I believe it's called camel casing, but the first character is always going to be lowercase, and then all the words afterwards are going to be uppercase. So if you had my first integer, the F would be also capitalized as well as the I. So that would be that naming convention. And then for methods, you're going to start them with an uppercase, and then all the words following are also going to be uppercase. So what we're going to go ahead and do here is we're going to create another variable, and this one is going to be a long. So this is going to be my long, and we can make that equal to 3. So the difference between long and integer is what values they can actually store. So the integer values you can store is from roughly about -2 billion to positive 2 billion. And I'm actually just going to copy paste those values exactly into this video here. So these would be the numbers that you can store in an integer. And then for a long, it is going to be a very, very large value. It is going to be, I don't even know what value this is, but -9, and then a bunch of other numbers to a positive 9 and a bunch of other numbers. So they're very, very large numbers. In the most case, an integer is probably going to be fine, but you might need to use long in some cases if you're only using whole numbers. Now, there are different variable types for decimal values, and you are probably going to be using decimal values for the most part, especially if you're doing divisions and you want some exact values. So the first one is going to be called a float. So that is just going to be float, and we're going to name that my float. And for that, we can do 4.02, let's say. And if we do a semicolon, because all the lines in C#, as you've noticed, do need a semicolon at the end to distinguish the end of the line, it's actually going to show us that we have an error right now. And that's because for a float, we need to add an F at the end here. And actually in Visual Studio, if you actually just hover over top of this, it's going to tell you literal of type double. So for some reason, yeah, the literal of type double, because this is currently actually a double, cannot be implicitly converted to type float. Use an F suffix to create a literal of this type. So we can just do an F here. And then, as you probably know, based on that, the next one is going to be a double, where we can name that my double, and we can make that equal to 4.02, and then the semicolon. And then there's one last variable type for decimals, and that is actually just decimal itself. We're going to name that one my decimal, and that is going to be 4.02, and that one needs a suffix of an m at the end. That's going to distinguish a decimal. Now, the main differences between all of these is the my float can do a 7 point after the decimal, or 7 digits of precision. And the my double can do 15 digits of precision. And then the my decimal, or the decimal value, can do 28 digits of precision. And the way that we can actually tell that is by actually testing printing these out to the screen. Now, to print out to the screen, as you've seen with the template, that is achieved by referencing the console.writeLine. And then in here, we can actually put in a variable. So let's actually just try to print out my float for now. And then we can just put a semicolon. So if we actually do this here, we will see that it exited with 0. Press any key to close the window. And we can actually see that 4.02 is actually printed on the screen. So if I actually just zoom in here, you guys can actually probably see that a little bit better here. So we can see that the 4.02. So let me actually just go back. All right. So let's exit out of the screen. What I usually like to do is, after my console.writeLine, just to keep the console nicely open with no other garbage in there, it's just a console.read, open and close parentheses. And here we will see now we only see that 4.02. So let's actually see what they mean by 7 digits of precision. So let's actually do a 4.12345678 9. So here we have 9 digits after the decimal. So let's see what that looks like. So let's actually just zoom in here. We're actually already zoomed in. So as you can see, we only get 4.123457. So we only have 6 digits, so 7 digits in total of precision here. And then if we go ahead and do the my double, so let's actually just copy paste this 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 1, 2, 3, 4, 5, 6, 7, 8, 9 again. And let's actually just print out, instead, we're going to print out the my double here. And we're just going to launch that. So here, as you can see, we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15 digits here of precision. So that is actually perfect. So I do believe maybe that this one is actually 6 digits of precision and not 7. So that is actually perfect here. And then we have the my decimal, which is 28 digits of precision. So if we actually just go ahead and copy paste 3 of those here and change this to my decimal. And let's go ahead and let's launch this. So here we have the value. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, and 28. So there's your 28 digits of precision. So that covers pretty much the 3 data types. Now, when would you use these? So the floats are probably going to be mostly only used when you're programming graphics, especially in Unity. Unity uses a lot of floats. If you're doing any type of calculations that aren't related to financial applications like money or anything, you could definitely use the double. That would be probably the most accurate method of doing it. This would be like if you're programming again, kind of like a game. If you're calculating any type of like stats or anything, that would be a great tool to use. And then the my decimal is used for financial applications. So any type of calculations that involve money or accounting of some sort, you would definitely want to use the decimal data type to be as accurate as possible. All right, so then that brings us to our next variable type, which is going to be the Boolean, and that is declared by doing a bool. So let me just zoom back out here. That is going to be distinguished by a bool, and we are going to be is daytime. And for me, that would actually be false currently because it is 9:34 p.m. So it is definitely not daytime where I am here. But here we have the bool, and we have our name again, and we have our value, which can be either true or false. And then once again, we could actually print this to the console. So we can do a console write line, and then an open parentheses is daytime, close parentheses, and semicolon. So if we run that here, we can actually see we have our decimal, and then we have our false answer here. So that is perfect. So let me just zoom back out here. And this brings us to our last two data types that we are going to be covering today, which is going to be the character and the string. So for a character, this can only hold one single character. So this probably won't be used as much. So we're going to call it my letter. And let's go ahead and let's do single quotes here. And let's do the letter J here. And then we also have a string. And let's do it my name. And let's do, so in C#, I believe, if I remember correctly, the single quotes are only for characters. If you're referencing a string, you will have to use the double quotes. So that is something slightly different than in PowerShell. In PowerShell, you could represent a string in single quotes or double quotes. The only thing that was affected was how the variables were treated inside of that string. But in C#, if you're referencing a string, you will have to do double quotes for a longer string. And let's actually just go ahead and let's put a space in here. So with strings, of course, we can always output them to the console, of course, just like we can the character. But let's go ahead and let's output that name to the console here. So if we zoom in on that here, we can see that we get the JackedProgrammer string. Now we actually have a lot of abilities with the string type. So what we can do is we can directly manipulate it right in the console write line here. So let's do console write line. We're going to open up and we're going to do my name. And then if we do a dot, we get a bunch of different things that we can do to it. So we can do a replace, a to lower, normalize, to erase. So very similar to PowerShell. When we did a dot, we would get a list of methods that you can do to it. Now, what you can do to a string in C# is very, very similar to what you could do to a string in PowerShell. So I won't be going over this too much. But something that we can look at here is a substring. So let's take a substring of my name. And we see here that we can start it at a specific index here. So we're going to start at index 0. And we're going to grab the first 6 characters. And we're going to go ahead and do that semicolon here. So let's just do a run. So this will get us just the jacked out of JackedProgrammer. Now, if you wanted the programmer, now C#, just like PowerShell, starts at index 0, as you can see here that I specified to start at 0. So if we wanted to grab the P, this will be 0, 1, 2, 3, 4, 5, 6, 7. And then the word programmer has 10 letters in it, so we're going to do 10. So if we run this here, we can see that we just get programmer here. So definitely that is another thing to remember. C# as well as PowerShell does start at index 0. So any type of arrays, which we will be seeing later on, because those are definitely a lot more complex than these data types. But those will always start at index 0. And if you're going through a string, the index also starts at 0. So that's just really important to remember. Now, the other thing that we can do with C#, because we have all these different types of values here, and as we know, we might have some integers, but maybe eventually we might want to divide the mylong by 2, and we actually want to get that value. Now, currently, if we divide mylong by 2, we're just going to get, I believe it's going to be 1 or 2. So let's actually take a look at that. So let's initialize mylong. Let's just initialize down here so we can actually see what happens. So we can do a console dot write line, and let's do some arithmetic here. So let's do a mylong divided by 2. So as we can see here, the mylong divided by 2 gave us 1. So that's not going to be very good, because if we're actually trying to get the actual value, it should be 1.5. Now, the way to do that in C# is you can use what's called conversions. Now, there are 3 types of conversions in C#. There are implicit conversions, explicit conversions, and type conversions. So let's go ahead and let's just take a look at the first two, explicit and implicit conversions. So one of the things is explicit conversions will let you shrink data types down. So we're going to be specifically casting, let's say, a double to an integer. So what I mean by down is you would have long, mylong 1 here equals 3. So if you're explicitly converting, you can go downwards. But if you're implicitly converting, you can only go upwards. So an int cannot take a decimal value. And then the same thing, float cannot take a double value, but a double can take a float value. A decimal can take an int value. So you cannot go down. So you cannot go down in the method of precision, because integers take a lot less space to store compared to a decimal value. So let's actually look at this in practice, just so that makes a little bit more sense, because I know that that could be a little confusing. So let's actually just keep this to mylong as 3 here. So then what we're going to do is we're going to do an implicit conversion. And let's just do that under here. All right, so the implicit conversion would work in the way of, let's say, if we do a int num equals 2, and then we have a long big num equals num. So this will work because I can actually take a int into a long. But if I was to actually go backwards here, so if I do a long, we're going to do a big num2 equals as 30, and we do a int num2 equals big num2 we will see that we get an error because it cannot implicitly convert the type long to int. As I said, we can't implicitly convert downwards. So an int cannot be a long, a float, a double, or a decimal, but a decimal you can implicitly convert from a double, float, long, or int. So here, if we do the same thing and we do a decimal num2 equals big num2, that we have no problem. So implicitly conversion, we can go from an int to a decimal, but we cannot go from a decimal to an int. But now if we do explicit conversions, this will let us shrink those values. So where we had a long big num 3, let's say, and that was equal to 100, what we could do is we can do int num3 equals big num3. Now we get that error again, but what we can do is we can actually do a int here in brackets right in front of it, and that will actually explicitly cast that value. So what we can do is we can actually make this a little bit more visible here. So let's actually do some print statements here. So we're going to start with the implicit conversions. We're going to show you what those look like. So let's do a console.writeLine. And we are going to write big num. And then we are going to console.writeLine big num2 divided by 2. And then what we're also going to do is we're going to do a num2 divided by 2. So let's look at what the implicit conversions look like first. And 30 is actually a bad example because that is an even number. So let's do 31. And that will actually give me a much, much better example. All right, so let me just zoom in here for you guys. All right, so here is our values. So we have our big num, which for some reason is showing up as big num. Yeah, so big num here is 2. So as we can see, that's perfectly fine. And then when we do a console.writeLine big num2, which is a long, and we divide it by 2, we get that issue where we only get 15 instead of 15.5. But then if we looked at our implicit converted version where we've actually said, no, actually store that big num2 into a decimal and then divide that by 2, we get the 15.5. So we've actually implicitly converted that value into a decimal. And then here, if we actually change this to a, let's change this to a double here, a big num, and then let's change that to this value here. And then we are going to do a console.writeLine big num3. And then we're going to do a console.writeLine num3. And let's take a look at what this looks like now. So here we can see we have our big num3 here, which is our double. So we have our dot notation. And then once we explicitly convert that to an integer, we lose that decimal point and all the value afterwards because we told it we no longer want you to be a double. We only want you to be an integer. So that lets you convert any variable into any other, any type into any other type. You don't have to only implicit convert. You can tell a decimal to become an integer, but it will not allow you to do that without specifically saying, I want you to do this, because it doesn't want you to lose that precision by accident. So now what we also have is a type conversion. Now what this is, it will actually let you take a value like myFloat or myDouble and convert that to a string. So what that looks like here is actually going to be a string, and then we're going to call that myDouble string. And if we do myDouble here, we can do that a 2. And there's a method on our myDouble, which is called toString, open, close parentheses. And we actually get that. And then if we do a myDouble string dot, we will actually see that we get all the options that a string would have. So you can convert any numerical value into a string. You can also convert Boolean values to strings as well. Now, I don't know if this would actually be useful in an application. It could be very, very specific usages. We won't really be doing that too much in our videos, but what we will be doing is converting string values to integers or other values. Because what we're going to be doing is we're going to be taking input from our users, and when we take input from users, by default, those always come in as a string. So the way that you would convert a string into a number would be to actually parse that string for the value. Now, what we can look at is, as an example here, we have string my number 1 equals, and we're going to put our number here as 2, and we're going to have string my number 2 equals, let's equal to 4, and then let's do a console dot write line my number 1 plus my number 2. And if we run this here, actually it's still open. All right, perfect. So here we have our values here. So as you can see, we get a very unexpected value of 24. Now what this did is it added the string 2 to the string 4. So all we did was concatenate the two strings. So what we're going to do here, and let me actually just zoom out so you guys can actually see the whole screen. What we're going to be doing is we're going to be actually converting these strings to numbers so we can actually add them together. So what we need to do is we need to do let's convert them to doubles per se. So let's do a double. It's going to be my number 3, and we are going to make that equal to double in an uppercase double. So we're referencing the class double. We're going to do a dot parse, and we are going to parse my number 1. And then we are going to do the exact same thing here. For my number 4, we are going to parse the my number 2. So here we're going to do my number 4 plus my number 3. So my number 3 plus my number 4. And we should actually get something much better here. So let's go ahead and let's look at this zoomed in for you guys. So here we have the value of 6, which is what we've expected for a 2 plus 4. Now, as we know, users might not always enter actual numbers when we're asking them. They might give us letters, which would definitely throw things off and cause problems in our script. But we're actually going to be looking at that later on when we look at some simple decisions and some conditions. We are going to be able to actually check whether or not they've inputted a valid number. But just to show you guys what that would look like is double my number 5, let's say, and we have a double, and we have a TryParse. Now what a TryParse does is it returns a Boolean, value of either true or false, whether or not it was able to convert that string into a number. So we could easily check to see if the user has entered something that is able to convert to a number. If not, we can reprompt the user to enter something else. But if it did, then we could take that number in and continue our calculations. So that covers pretty much everything that I can really think about with data types and variables, except for, of course, the arrays, which we'll be looking a little bit later because those are a little bit more complicated. But that should you guys get pretty much started with variables in C#. If you guys have any questions, let me know down in the comments below, and I will make sure to answer them as quickly as possible. If you guys want to see anything specific in this C# tutorial series, let me know down below in the comments and I will do my best to cover that topic. Make sure to hit that like button and subscribe button and hit that notification bell to be notified when that next video comes out, and I will see you guys on the next video.